In today's lesson, we are going to talk about the distance and midpoint formulas. You have seen these concepts already in 7th grade as well as in geometry. So if I am going to find the distance between 2 points, the first point is x1, y1, and the second point is x2, y2. Basically, I am going to find the length of the segment that connects these 2 points. And to find this distance, we can use the Pythagorean theorem. As you remember, the Pythagorean theorem is c squared equals a squared plus b squared, where c is going to be the length of the hypotenuse, a is the length of one of the legs, and b is the length of the other leg. So in this particular triangle, if I'm looking at the length of the hypotenuse, that will be my distance squared, and that will equal to the length of the horizontal leg squared plus the length of the vertical leg squared, which is y2 minus y1 squared. If I want to find the length of the hypotenuse, I have to take the square root of both sides, and my resulting formula is the distance between the 2 points is the square root of x2 minus x1 in parentheses squared plus y2 minus y1 in parentheses squared. In our first example, we need to find the distance between 2 points, 2, -4 and -5, -1. We are going to do this in 2 different ways. First, we are going to graph the 2 points. So we have 2 and -4. So I plotted my point there. And my second point is -5, -1. And then I'm going to form my right triangle. And now we are going to use the Pythagorean theorem to find the length of the hypotenuse, or the distance between the 2 points. So I'm going to first find the vertical distance, which is 3 units, and my horizontal distance, which is 7 units. So if I want to find c, which is the hypotenuse, c squared will equal to 3 squared plus 7 squared. So c squared will equal to 9 plus 49. C squared will equal to 58. And finally, the distance between the 2 points, or c, which is the length of the hypotenuse, will be the square root of 58. And now I am going to use my distance formula, which is distance equals the square root of x2 minus x1 to the second power plus y2 minus y1 to the second power, to verify that I got the correct answer with my graphing method. So first I'm going to label the 2 ordered pairs. This is my x1 and y1. This is my x2 and y2. So now I am going to substitute into the formula. The distance equals the square root of -5 minus 2 squared plus -1 minus -4 squared. So the distance will equal to the square root of -7 squared plus 3 squared. So the distance will equal to the square root of 49 plus 9. The distance then finally is going to be the square root of 58. So as you can see, it didn't matter which method I used to find the distance. I ended up having the same distance both ways. The second formula we are going to look at today is the midpoint of a segment AB, where the endpoints, the first endpoint is A, and the ordered pair that represents that endpoint is x1, y1. The second endpoint is B with coordinates of x2, y2. To find the midpoint of this segment is going to be a formula we use where we are going to take the sum of the x coordinates and divide it by 2, and then we are going to take the sum of the y coordinates and divide that number by 2. So basically, to find the midpoint, we are going to take the average of the x coordinates of the endpoints and the average of the y coordinates of the endpoints. We are going to find the midpoint of a segment that is joining points 6, -2 and 2, -9. So we are going to use our midpoint formula, which is x1 plus x2 divided by 2 and y1 plus y2 divided by 2, or the arithmetic mean between the endpoints. So if I call this point here x1, y1, and call this second point x2, y2, to find the midpoint, I am going to say 6 plus 2 divided by 2 and -2 plus -9 divided by 2. And after simplifying, we have to simply say the midpoint is 8 divided by 2, or 4, and -11 divided by 2, or -11 halves. In the last example, we have to write the equation of the perpendicular bisector of segment AB with the given ordered pairs of 2, -5 and 4, 7. First, we have to define what a perpendicular bisector is. A perpendicular bisector of segment AB, any segment AB, is a line, a ray, or a segment that passes through the midpoint of segment AB and is perpendicular to segment AB. So to find the perpendicular bisector of segment AB, we have to take several steps. Step number 1, we have to find the slope of segment AB. So first we are going to find the slope of segment AB. To find the slope, we have a formula which is y2 minus y1 over x2 minus x1. So it's 7 minus -5 over 4 minus 2, which is 12 over 2, or 6. So now to find the perpendicular slope, we have to take the opposite reciprocal. So the slope of the line perpendicular to this line will be m equals -1/6. The second step of finding the perpendicular bisector is finding the midpoint of segment AB. So to find the midpoint of segment AB, we are going to say 2 plus 4 over 2, and we are going to say -5 plus 7 over 2. So the midpoint is going to be 6 divided by 2, which is 3, and 2 divided by 2, which is 1. So now we have to write the equation. We have a point on the line on that perpendicular bisector, and that point is the midpoint of the segment. And we also have the slope of this perpendicular line. So I'm going to start out with y equals mx plus b, substituting in the coordinates of the midpoint for x and y. I get 1 equals, the slope is -1/6, and the x-coordinate is 3 plus b. So all I have to do is solve for the y-intercept. So I'm going to go ahead and do it up here. So it's 1 equals negative 1/2 plus b. And if I add 1/2 to both sides, I get b equals 3/2. Now I have my y-intercept and I have my slope. So my final task is to write the equation of the perpendicular bisector, which will be y equals negative 1/6 x plus 3/2.